Alright, so in this video we are going to do a work and power calculation. This is going to be number 17 from your study guides. Again, this is number 17. It is the third problem under work and power. And without further ado, we'll just get started here. So, how much power is used if a force of 90 newtons is used to push a box a distance of 30 meters in 10 seconds? So we just read through the problem, and the next thing we have to do is define what variables we are already given. So, in this problem, we know that we have a force being applied to a box of 90 newtons. So our F is going to be 90 newtons. We also know that it's going to be pushed a distance of 30 meters. And this whole process is going to take about 10 seconds. So that is our time right there. And what we need to figure out is the power. That's our final answer. But to find power, we have to know work, because power is calculated by the work divided by time. So the very first thing we have to do is figure out work. In this problem, we can easily do that because we know that work is force multiplied by distance, because we have the formula for that. So we will plug our variables into that, and we will get that W, or work, equals a force of 90 times 30 as our distance. And what we should get here is that our work is going to equal 2,700 joules if we plug that into our calculator. So 2,700 joules is going to be our work in this problem. So we can fill that in as our next variable. And then I'll erase my work here. So now the nice part is, if I have my work, I now can figure out my power because I have every variable that I need. I have the work and the time. So the next step here is all I have to do is plug back into this formula. So power equals 2,700, which is our work that we just powered, divided by how long it took to move the box, which was 10 seconds. So should be some simple math here. 2,700 divided by 10, that should give us a power of 270. And don't forget, what are the units of power? We do not measure them in joules, but instead we measure them in watts. You might be familiar with watts because you've seen a 60 or a 40 watt light bulb. That is the measure of the power output of that light bulb. So realistically, or the power consumption of that light bulb. So realistically, we have 270 watts would be our final answer for number 17 in your study guide. And it's not too bad. All you have to do is calculate the work first using the provided equation. Everything's already given to you variable-wise. And then once you have your work, you just have to re-plug it back into the power equation. And we should get that it is 270 watts is our power used in this problem. Hopefully this was helpful. Email me if you have any questions.